Horrified by what he'd just done, all Benjamin Jesse could do was stare into the fireplace, speechless. It was the year 1774. Ben had approached his cow, Elsie, who'd become infected with cowpox. He then gently grabbed her udders and scraped pus from the cowpox blisters. Then he took Elsie's pus into the house and proceeded to scratch it under the skin of his wife and 2 sons. Just weeks before, his dear friend had awakened. His whole body was aching with a sore throat, shortness of breath, and a fever. Then his nightmare began. He developed a rash over his entire body. The pustules covered his scalp, his feet, his throat, even his lungs. The pus dried and the scabs sloughed off, leaving him scarred and disfigured. This was the plight for those who contracted smallpox, likely the worst disease humans have ever battled. With the death toll as high as 80% in the case of children, the urgency to eradicate this disease was global. Many common folk remedies were employed to manage and control this disease. One modality put the sufferer into an extremely cold room, uncovered with the window open. Some infected people chose to abstain from eating melons. Others draped their body in red cloth. Forward thinkers avoided touching their blisters by holding a glass of wine in each hand and by eating raw garlic to keep everyone a safe distance away. Finally, it was recommended the infected person drink 12 bottles of beer every 24 hours. Folk treatments aside, there was an actual cure. Variolation. In today's form, what we'd call inoculation. That's what our hero Ben was doing when he scraped pus into his family's skin. The idea of inserting an animal disease into a human caused many people to recoil in fear that they would morph into a hideous horned beast. A British physician called Edward Jenner sought to make this less terrifying. In 1796, he found a milkmaid called Sarah Nelms with fresh cowpox lesions. He used pus from her lesions to inoculate an 8-year-old boy. James Phipps was inoculated again 2 months later from a fresh lesion. Little James never did become infected. Ed knew that his remedy had the potential to save thousands and thousands of lives. He also knew that he could only stop the disease if he scraped pus into everyone. He converted a small one-room house in his garden into what he dubbed the Temple of Vaccinia. He invited local folks to come by after church to be vaxxed at no cost. Edward shipped his cure all over the world, and he never made any money from his invention. Smallpox, by the way, was not completely eradicated until 1979. Before 2020, the average time to create a vaccine was between 10 and 15 years. A better approach has been on the horizon for many years using RNA. RNA vaccines, or mRNA vaccines, use messenger RNA, which is a molecule that delivers instructions to your cell to make specific proteins. These proteins are what enable the virus to reproduce once it attaches to your cell. In the case of coronavirus, this is that familiar spike. mRNA is like antivirus software for your biology. It updates your malware database to detect the virus and provides instructions to defend against the threat. Unlike traditional vaccines, no actual live virus or deactivated live virus or no anything that was formerly alive is actually injected. There's no need to wait for cultures to grow in a lab, and it's extremely fast to produce. With mRNA, it's super easy to insert new genetic sequences into the platform to adjust for variations. This technology is not new, but it has struggled through its 25 years of university research. That was until 2020, the year that literally went viral. Seriously, the hair salons were closed. Things got really ugly out there. The urgency around the globe to stop COVID is unheard of in human history. The level of financial support, resource sharing, and cooperation between governments, companies, institutions has been unprecedented, including even the sharing of proprietary data. This is a game changer. Here's how it went down. On December 31st, 2019, COVID-19 was first identified. 5 days later, the full sequence of the genome was obtained. From there, it took just 8 days for the initial vaccine to be finalized at Moderna, and within 63 days, the first phase 1 dose was given. Going forward, mRNA technology will likely be the way we vaccinate against viruses. It unfortunately does not protect against bacterial diseases. And if you're worried about a nanochip being embedded in the vaccine, take a deep breath. We're nowhere near the level of technology that would allow scientists to do that. And anyway, you already have a device in your pocket which captures every moment of your life in great detail. Your next flu shot will likely be mRNA based, so you better get over it. The good news is you'll only need to get poked every 5 years. The use of RNA technology is revolutionizing medicine, with cures advancing for Ebola, SARS, Zika, HIV, melanoma, and soon we'll have cancer cures personalized for the individual's specific mutation. I am glad we'll no longer be jabbing the modern equivalent of pus into our arms. We're vaxing our way into a new era in human development. The future of medicine never looked so bright. Can I get a shout out for 2020? Woohoo! 2020!